This is an Atwood machine. We have a massless pulley and we have two masses, and let's consider that mass 1 will be 8 kilograms and mass 2 will be 10 kilograms. That means that the force due to gravity will be mass times g, meaning 80 newtons pretty much and 100 newtons. Now we consider the pulley to be massless. Everything will change if the pulley had a mass, and we're going to see that in rotation. So now we have two masses, they're not equal. If they were equal, the system wouldn't move, but now the system of the two masses will move. And we expect it to move towards the heavier. That means that this one will accelerate upwards while this one will accelerate downwards. Now the first thing that we do, like I will show the traditional way and I will show the fast way. So the traditional way starts by doing the free body diagram for each object separately. The forces on mass 1 is the force due to gravity 1 and the tension upwards. For mass 2 we have its own force due to gravity Fg2 and the tension. I use the same symbol for tension because these two tensions are the same according to Newton's third law, because the forces that the two objects pull each other should be equal. So the two tensions are equal. Also, the two accelerations will be equal because the two objects are attached to the string, so they have to do the same motion. There's no way they can do something different. So starting from the free body diagram, I make sure that this force is longer than this, just because the force is bigger than that. Well, the two tensions are the same. That means that these two lengths should be equal. And apparently, the second force due to gravity, Fg2, is bigger than the tension because the object moves downwards. Well, for this is smaller than that because the object moves upwards. Now, finishing the free body diagram, I go here and I write for each object the sum of forces for x and y axis and the Newton laws that happen. So for object 1, for both objects 1 and object 2, the sum of forces on the x-axis are 0, no horizontal forces. Now, the sum of forces on the y-axis equals mass acceleration. So for object 1, we have mass 1 times acceleration. For object 2, we will have mass 2 times the acceleration. So if I consider them both positive, that means that I consider, for this one, I consider the upwards motion to be positive and the downwards to be negative. And then if I consider this to be positive, that means that I will consider this to be positive and this to be negative. So continue with object 1, the sum of forces on the y-axis are the tension minus the force due to gravity, and they should equal the mass times acceleration. Knowing that the force due to gravity is 80, I have this equation that says tension minus 80 equals mass times the acceleration. Going to the second object, I have that the force due to gravity 2 minus tension equals second mass times acceleration, which is 100 minus t equals 10 times the acceleration. Now, I have made a system of two equations with two unknowns. This is the one equation, and that's the other one. And the two unknowns are the tension and the acceleration. So let's say by solving both equations for tension and then making them as equal, I can do math and find the acceleration. So I find here, from here, that actually if I write it up here, I can find that the acceleration will be 100 minus 80 over 10 plus 8. And I can do the math. Now, why do I keep this equation and don't just do the math, because I want to show you the easiest way. The easiest way to find the acceleration is by using this formula that says that the acceleration will be found by the total moving force over the total mass. Apparently, the total mass is the sum of these two forces, the two masses, 10 and 8. And this is what I actually have here, 10 plus 8. So I do have what I need here, the total mass. This is what I need to have in the denominator. Now, what about the numerator? So what is the total moving force? Total moving force in the numerator. I have two forces that actually oppose each other. I have the force due to gravity pulling in. I have to go this way. So I have the force due to gravity 2 pulling that way, and the force due to gravity 1 pulling the other way. Apparently, the force due to gravity 2 is stronger, so it will pull. It will pull the object. But again, this exists and tries to cancel out force 2, right? So actually the total force, the remaining, is found by subtracting these two, because these two oppose, okay? They're opposing forces. So the total moving force will be found if I subtract these two. The force due to gravity 2 minus the force due to gravity 1. And this is what I actually have here. All right, this is what I have here. So either I do the traditional method, meaning doing the free body diagrams, solve for the sum of forces on the x and the y axis for each object separately, and then make an equation, a system of two equations with two unknowns to find the acceleration, or I use this formula that says total moving force over total mass.